Let's solve this rational inequality. Now, as soon as I see this greater than sign, I know that this is going to be one of those problems where I am plotting some critical values on a number line and I'm doing test values to see where the solutions are. Now, how do we figure out which values to plot on the number line? What are the critical values? For rational functions, they come from two sources. One source of critical values will be any excluded values. The other source will be we'll solve the problem as an equation, and those will be critical values. So either way, we are going to need to factor this problem. So in factored form, the numerator is x plus 4, x minus 4, because this is the difference of two squares. And then the denominator, x squared is going to factor as x times x. 5 can only factor as 1 times 5. Now inner plus outer must equal middle. Inner, I have 1x. Outer, I have 5x. If I want a middle of negative 4, I need a positive 1 and a negative 5. So positive, negative, like that. Also, a positive times a negative will give us a negative 4. Sorry, I'm pointing at the wrong thing. Positive 1 times negative 5 will give us the negative 5 that we want. So now it is factored. So it's easy to see the critical values. So first of all, the excluded values are going to be that, I'll put them up here, x cannot equal negative 1 because of that, and x cannot equal positive 5. Imagine setting this equal to 0. Alright, so those will be values that will be plotted on my number line in a minute. Now, for the other critical values, I need to make this an equation instead of an inequality, and I need to go ahead and solve it. Okay, so one way to solve rational equations is to make the denominators be the same thing. So this 0 is like 0 over 1, so I can just make the denominator whatever I want. In this case, x plus 1, x minus 5, to match this. That's valid as long as I put the same thing in the numerator, x plus 1 times x minus 5. Alright, I've put the same thing in the numerator and denominator, so I'm not really changing anything. Once you have like denominators, you can cancel the denominators out. So now I have x plus 4 times x minus 4 equals, now look, 0 times anything is just 0. So I really just have 0 over here. Now, I can solve this by setting each of these factors equal to 0. So that's going to give me x plus 4 equals 0, x minus 4 equals 0. So x equals negative 4, and x equals positive 4. Okay, so these are my additional critical values, negative 4 and positive 4. Alright, so x equals negative 4, x equals positive 4. So all 4 of these values need to go on my number line. So I think I'm going to need more space for this number line. Okay, so I'm going to make a nice big number line because of all these values. Alright. Now, excluded values are always graphed as open circles. Well, you know what? I better wait and see which numbers are which. Getting too carried away. I really need these to be in order. So let's see, my leftmost value is this negative 4. And then comes negative 1. And then comes positive 4. and then comes positive 5. Now, as I was saying, excluded values are always graphed as open circles. So I'm going to put an open circle at this -1 and an open circle at the 5. Now that makes sense because open circles indicate that this particular value is not to be included in the solution. And of course we don't want to include values that are excluded. They're illegal. On the other hand, the critical values that we got by solving the equation, sometimes they are open circles and sometimes they are closed circles. It depends on whether we just have a greater than, all right, which would be an open circle, or a greater than or equal to, which would be a closed circle. Now this makes sense because these values that came from the equation are values that make the function equal to 0. So if we want the values where the function is greater than or equal to 0, then we're going to include the values that make the function equal to 0. And we'll show that with a closed circle. And that's the case here. We want the values that make the function greater than or equal to 0. And these critical values make the function equal 0. So we will include them. All right, by making them closed circles. Okay, so now we need to do our test values and find out where the solutions are. So in this zone, we need something to the left of -4. So for example, I could evaluate the function at -5. Between -4 and -1, I could do -3 or -2. I'll just do -3. Between -1 and 4, I could do 0 or 1 or 2 or 3. I'll do 0. Now between 4 and 5, these are consecutive integers, so I'm going to have to do a decimal. So I am going to do 4.5. Alright, just halfway between 4 and 5. Now to the right of 5, I just need something bigger than 5, so I could do 6. I could have done 7 or 8 or what have you. So these are the 5 test values that I'm going to use to check and see where the solutions are. So I'm going to use my calculator to make this process go faster. So I'm going to use my table feature, and I'm going to type the function in x squared minus 16 over x squared minus 4x minus 5. Make sure your calculator is in Ask X mode. Alright, so my first 3 values are -5, -3, and 0. So I can do -5, -3, and 0. So these are the values that I get. So 9 over 40 okay, let's see. So 9/40ths, -7/16, and 16/5. All right. Also, now we'll do 4.5 and 6. So we'll delete this. So 4.5 and 6. So I have -17/11ths and I have 27ths. Now in each case, I want to know whether or not the function is greater than or equal to 0. So is this greater than or equal to 0? Well, it's positive, so yes. Is this greater than or equal to 0? Well, it's negative, so no. How about this? That's positive, so it's greater than 0. How about this? That's negative, so it's not greater than 0. How about this? That's positive, so that is greater than 0. So the yeses show us where the solutions are. So there are solutions here, which I will show with an arrow. There are no solutions in this zone. There are solutions here between -1 and 4. And there are solutions here that are greater than 5. So I have these 3 intervals that when I write my solution in interval notation, I will join them with the union symbol. So this one goes from -infinity to -4. So I've got -infinity to -4, and I will use a square bracket to show that this point is included in the solution, just like we showed with the closed circle. Union, and now here comes the next interval, which is from -1 to 4. Notice I used a round parenthesis on the -1 for the same reason I did an open circle, and I used a square bracket on the 4. That's a closed circle. I want it to be included. And now there's a gap here, so I'm going to put union, and then one more interval goes from 5 to infinity, a round parenthesis, because this 5 is not to be included. Alright, infinities always get round. So this is the solution, so I'm just going to look for it among the options. So let's see, -infinity to -4 with the square bracket. So I've got it down to either A or C so far. Let's see, -1 to 4 with the bracket on the 4. So that means the answer is going to be C. It's only one left, but sure enough, 5 to infinity with round parentheses. So the answer is C.